So in this lesson, we're going to focus on two learning targets. The first is we'll be able to convert between roots and fractional exponents. So we'll be able to determine, okay, what is the fractional exponent of this root here? Or what is the root of this fractional exponent here? Then we'll also be able to evaluate expressions that contain fractional exponents, specifically with a numerator of 1. So before we tackle fractional exponents, we need to talk about a root and what exactly a root is. So at this point in your math career, hopefully you know that the square root of 9 is 3. And it's 3 because 3 times itself is equal to 9. So a square root really has an invisible 2 there. And what we're trying to figure out when we solve a square root is we're trying to figure out what number times itself 2 times gives us 9. In this next example down here, you'll notice that we have a 3. And what that 3 is stating is it's saying what number times itself 3 times, or what number to the power of 3 gives us 64. And so if we start to test out a variety of numbers, what we find is that 4 to the power of 3 gives us 64. So the cubed root of 64 is 4, because 4 to the power of 3 gives us 64. This next one down here has a 4, so what this is saying is what number times itself 4 times gives me 81. I need to figure out what my x value there is, and if I start experimenting with numbers, I notice, okay, 2 times itself 4 times gives me 16, but 3 times itself 4 times gives me 81. So the fourth root of 81 is 3. And then if I look at this last one here, this one is saying what number times itself 5 times, so x times x times x times x times x, is going to give me 32. And if I start experimenting with numbers here, I find that my answer would be 2. So when we're solving a root like this number is telling us what number times itself how many times gives us this number that is inside the root. So that by definition is what a root is asking us to find. Now everyone should have a powers resource, like we see below, filled in. So you need to go through and fill in, okay, all of these powers of 2. So you'd say 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, 64, 81, 100. And then you need to go through with your calculator and fill in all the third powers, fourth powers, fifth powers, and sixth powers. If you want to do more, that is fine. But this is something, if you don't have a copy of this, make sure you see me in class. But this powers resource is what we're going to use on the next few slides to help us to quickly solve problems that involve roots and fractional exponents. So we're not going to use our calculator. Instead, we're going to use this powers resource to help us. So now we're going to use our powers resource to evaluate the following expressions that contain roots. So if we look here, we see that we have a square root. Remember, there's really an imaginary 2 there. So it's asking us what number squared gives us 49. And if you look down the squared column in your powers resource, you will find that 7 squared gives us 49. So the square root of 49 is 7. Then if we look at part B, this one has a 3. So we're looking for what to the third power gives us 216. And if we look down the cubed column, we find that 6 to the power of 3 gives us 216. So the third root of 216 would be 6. Then if I move on to part C, I notice I have the fourth root here. So I'm thinking what to the power of 4 will give me 625. And if I look down to the fourth power column, I'll notice that 5 to the power of 4 gives us 625. So the fourth root of 625 is 5. And then lastly, here I have the fifth root of the 1024. And if I look down the fifth power column, I notice that 4 to the power of 5 gives us 1024. So the fifth root of 1024 would be 4. So now that we've mastered roots, we're going to move on and focus on the relationship between fractional exponents and roots. And this is actually very, very simple. We can easily switch between a root and a fractional exponent. You just have to know the connection between the two. So what you're going to notice in each of these fractional exponents is that they each have a denominator. And what this denominator represents is it represents the number that's in the root of the roots we saw in the previous slides. So for example, here when we see 64 to the power of 1/2, this is really asking us to represent the second root of 64 to the power of 1. Now notice how the 1 stayed right with the 64. The 2 we brought out in front. We really don't need that 1 there. We can leave it there if we want. But what we can do is if we see this denominator piece here of our fraction, that goes into the root part. That's the number of the root. And then from here, because we know how to solve roots, we would say, okay, the second root of 64, what squared gives us 64? Well, that's 8. And then if I look at this next one, what I notice is I have a root with 512. I can include the first power or not. It's up to me. But then I need to note that this 3 in the denominator goes into my root. So I'm looking for, okay, what to the power of 3 gives me 512. And if I look in my powers resource, I note that 8 to the power of 3 gives me 512. So this answer would be 8. So now if I move on to my next example, this one I know I have the fourth root of 256. So I'm trying to figure out what to the power of 4 gives me 256. And if I use my powers resource, I find that to be 4. And then here we can rewrite this one as the fifth root of 32. So what to the power of 5 gives me 32? That would be 2. So here I can really easily take all of my fractional exponents, rewrite them as roots, and then I can use my powers resource to solve. Okay, so last 4 examples of this video. We're going to rewrite the following fractional exponents as roots and then evaluate the expression. So here I know that my denominator of 2 goes into my root. So I have the square root of 36. So I'm looking for what squared gives me 36. That would be 6 if I'm using my powers resource and look down that squared column. This next one here, the fractional exponent has a denominator of 4. So I have the fourth root of 2401, which if I look down to my fourth power column, I notice that the 7 to the power of 4 is 2401. So this would be 7. This next one here, again, 3 is in my denominator, so I have the third root of 729. So what to the power of 3 gives me 729? That would be 9 if I use my powers resource. And this last one here, we have a denominator of 6. So we're trying to think, okay, what to the power of 6 will give me 64? If I look down my power of 6 column, I find that that is 2.